you ever tried to stare at a picture illusion and notice that your brain signals and gathers information that it starts to move? And if you look at it, it will start to move after the picture illusion. Today I'm going to explain through examples, facts, and pictures of how our brain works. We use our brains every day by the way we talk, move, through emotions, sensations, and how we behave. It controls many parts of our body, and I will share how our left brain differs from our right brain, our different parts of our brain and how they work, and how the brain's nervous system is developed. Our brains are divided into two hemispheres, known as the left and right brain. The concept of the left and right brain was developed in the 1960s by a psychobiologist named Roger Sperry. The right brain is usually for those who are creative and are visual and in a simultaneous way. But the left brain is more like a person who's like more organized, responsible. They like to be structured. So say a person's giving directions to someone, the left brain would more be like, go down west, 3 blocks down Chapman and turn right. As a right brain person would be like, go down and when you see McDonald's, turn right on that corner, keep going down Lemon Street and you'll see a football field. But they're more specific in a way. The right brain is more of like a creative way, using like McDonald's as an example. According to mental math schools, one is not better than the other, just as being right-handed is not superior to being left-handed. What is important is to be aware that there are different ways of thinking, and you can pay attention to your less dominant side to improve your better side. So say if you're a right brain person, you can improve that side to be more of a left brain person, so not one is better than the other. Our right and left brain hemisphere controls the opposite side of our bodies, so the left controls right and the right controls left. So say a doctor diagnosed someone with a right brain tumor on the right side of the brain, your left arm or your left leg would possibly become paralyzed because of how the opposites contract. The brain has a lot of different parts and helps with our communication and body's decision. The cerebral cortex is the largest part of the human brain, with higher brain functions like thought and action. It is divided into 4 parts. So these are the 4 parts of the cerebral cortex, and they're called lobes. So the frontal lobe is located on the front of your brain. It helps with your reasoning, planning, speech, and emotions. Your parietal lobe helps with your movement, your orientation, and your recognition. Your occipital lobe helps with your visual processing, like how it helps you see in the light and day or the dark. Your temporal lobe is your perception. It helps with your memory and speech. According to Serendip Studio, white nerve fibers underneath the cerebral cortex carry signals between the nerve cells and other parts. Next is the cerebellum. It has a nickname called the little brain, similar to the cortex but has more highly folded surface. It is also split into 2 parts, right on the back of your brain, next to your spinal cord. So the back of your brain here is split into 2, so it is next to your spinal cord and the brainstem, and the spinal cord helps with your movement, and it helps with your balance, and also the brain cells help with maintain your breathing, your blood pressure, and your heart rate. And the limbic system is buried within the cortex, cutting in half. It also has 4 parts. The thalamus, the gray matter in your forebrain. The hypothalamus functions with the emotions, your thirst, and your hunger. Your amygdala is your temporal bone and helps with your memory, emotion, and fear. Your hippocampus is important for your learning and memory. Our brain's nervous system work together in order for our body to properly communicate its sensations and needs. It is split into 2 called central nervous system, as CNS for short, and peripheral nervous system for PNS for short. The forebrain, midbrain, and hindbrain and spinal cord from the CNS and nerves and small gray matter called ganglia are in PNS. How you learn and remember, the way you move and talk, or the beating of your heart, your digestion of your food, stress, and part of your brains are called nervous system. Messages are carried throughout the nervous by the unit called neurons. When a message comes into the brain from anywhere, the brain tells the body how to react. Like, if you touch a hot stove, you're automatically going to move your hand off the hot stove because your neurons are sending a message to your brain that it's hot and you need to move your hand because it'll get burned. So, and also how I showed you the picture illusion in the beginning, it's their neurons are sending brains to your message too, and it helps you know that the picture moves. Neuron anatomy says that the brain sends a message via spinal cord with variable nerves throughout the body that controls your muscles. The somatic nervous system connects the central nervous system with the parts of the body that interact with the outside world. Considering everything it does, the human brain is incredibly compact, weighing just 3 pounds. Its many folds and grooves provide additional surface area necessary for storing all the body's important information. So yes, your brain is always on the go.
So Jonathan, some comments, please.
Overall, you had a great speech. You had a preview, it was structured well, had great information. I like the examples that you used. You explained the pictures as well, you cited information, which is good. You used a lot of your note cards and you're reading a lot from them, but you had a lot of information and you had good visual aids. Overall, pretty good.
All right, well, I like the introduction. I like the attention device. I thought you had a clear statement of your purpose and a very good preview of what you're talking about. Organizationally, it's a very straightforward topical structure. It gets a little complicated because you've got so many parts that you're talking about. So here we're looking at all the sections, and then inside one of the sections we're looking at subsections, and then we're looking at another system that has a whole bunch of other concepts to it. And it's a lot of terms that get introduced in a short amount of time, and we don't get much chance to talk about each of them. My guess would be that if you were in an anatomy class, if you were taking a physiology class in a medical school, for instance, they probably spend 2 or 3 hours talking about each one of those little things that you just mentioned, and you're kind of scanning through things, and we don't get that much detail on it, which I thought was a little bit problematic. I know it's supposed to be a basic primer, an introduction to these concepts and parts, but you need to remind us of that as you go through it, and I think instead of worrying about getting all of the names right, which is fine, you do need to remind us about what the key ideas are, about what's different about each part of the brain or what its function is, that sort of thing. Just as an illustration, I like the visuals for the most part. I think that you use color pretty effectively and that the images are simple enough that we can see the differences that you're talking about. But once again, we get a lot of names and not a lot of reminder about what those things mean. On the right-left brain thing, for instance, okay, I've got a division there. I've got 2 colors on each side, but I get no references except your oral references to what functions or what it typifies right or left brain. And if there was some indicator, like organized, creative, on each side, that would have been a good reminder on that point. On the second slide where you have the sections of the brain done, if you maybe had the words outside of the brain and then maybe the function inside of those sections, it would have been a little bit clearer. As it was, because there's so much of it, I'm not sure that I'll be able to remember 2/3 of what you talked about. The cerebral cortex, that part, you spend a lot of time on, and that's, I think, probably your main function there. Maybe this would be one of those places where a little more subdivision and say, let's focus on this subsection and make this the point of the speech. That might have been a good choice. We're going to be talking more about delivery issues next time. We did an activity last Friday where I had the adjunct faculty, full-time faculty, all watching speeches from different classes, and we're trying to kind of standardize things. And we watched one of the speeches in our class last week, and I was the only one to give it a high grade. And everybody else was giving it really, mediocre grades because they were all emphasizing delivery issues. And I said, and somebody said to me, well, how could you give somebody an A if they never look at you? And I said, well, they did look at us a little bit, but because if you look at the evaluation form, delivery is only one or two of these items that is on the list. And then another class, we looked at the speech grade, and I gave the person a B, and other people were giving them an A, and they say, how could you give them an A? I said, well, how could they get an A for an informative speech when they didn't use any visual materials? But it wasn't required for them to use visual materials, so I was a little snarky about that. I guess I was maybe defending my students a little bit more. But I thought you did a nice job speaking to us for the most part. You look up pretty regularly. When you look down at your notes, it's just to get the information. Usually it seems like you know what you're talking about, and I appreciated that quite a bit. All right, thank you.